So, ji, assalamu alaikum. So, guys, we'll be solving February, March 2026. This is question paper 1, variant 2. Let's start. So, question number 1 says, what is the value of the ratio of 1 kilometers to 1 nanometers? So, 1 kilometers की अगर हम बात करें, 1 kilometer is 1 into 10 to the power 3, 1 into 10 raised to the power 3. Upon 1 nanometer, which is 1 into 10 raised to the power minus 9, which means you end up with 1 into 10 to the power 3 plus 9, which is 10 raised to the power 12. So the answer is B. Pretty straightforward. Question 2 says, what could reduce systematic errors? Averaging a large number of measurements that reduces random errors and not systematic errors. Careful calibration of measuring instruments, that is right. Calibration से systematic errors कम हो जाते हैं. Systematic errors is when your values are not close to the true value. That may be due to calibrations. Reducing the sample size, that does not help. Repeating measurements, that does not help. Repeating measurements help in case of random errors and not systematic errors. Question number 3 says, a student measures the current and the potential difference for a resistor in a circuit. Current is 50 plus minus 0.01. Potential difference is 500 plus minus 0.1. The measurements are used to calculate the new resistance of the resistor. What is the percentage uncertainty in the calculated resistance? R is equals to V upon I, which means percentage uncertainty in R is equals to percentage uncertainty in V plus percentage uncertainty in I. What is the percentage uncertainty in I? 0.01 divided by 50 multiplied by 100. ठीक है, ये 0.01 has the power 10 to the power minus 3 is multiplied to 10 to the power minus 3. वो मिली है, 50 भी मिली है, तो वो cancel out हो जाएंगे. We don't have to include it into 100. So this is 0.02%. 0.1 upon 500 into 100. So this also comes out to be 0.02%, which means 0.02% plus 0.02%, and that gives you 0.04%. The total percentage uncertainty, 0.04%. The answer is D. Graphs can be used to represent the motion of an object. Which relationship between a quantity of motion and a property of the graph is correct? Acceleration is area under a velocity time graph. No, that is displacement. Acceleration is the gradient of a velocity time graph. That is absolutely right. Displacement is the gradient of a velocity time graph. No, displacement is the area under the velocity time graph. Velocity is area under a displacement time graph. No, velocity is the gradient of a displacement time graph. The water surface in a deep well is 78 meters below the top of the well. A person at the top of the well drops a heavy stone down the well. Air resistance is negligible. The speed of sound in air is 330. What is the time interval between the person dropping the stone and hearing it hit the water? Now, this is something that this question has been asked earlier. And if you've done this, you know where students get stuck in. What is the time taken for the stone to fall down? We'll go with S is equals to UT plus half AT squared. And that gives you 78 is equals to 0T plus half into 9.81 into T squared. This gives you the value for T. So 78 into 2 divided by 9.81, square root of that answer is 3.99. So T is equals to 3.99. Yes, the values are also exactly similar. Options भी सारे same. अब majority students इस point पे क्या करते हैं? They'll take 3.99 as the answer because that is the time it takes. But that is the time it takes for the stone to fall to the bottom. See? You still have to take into account the time it takes for sound to travel up. Because the question says time interval between the person dropping and hearing. So sound traveling up, speed is equals to distance upon time. Hence time is equals to distance, which is 78, divided by speed, which is 330. So 78 divided by 330 and 0.24. 0.24. Keep in mind both values have been rounded up. So the total time is 3.99 plus 0.24. 3.99 plus 0.24. And that gives you 4.23. 4.23. The reason we get 4.23 and not 4.22 is because the actual value for the first time was 3.98 something and for the second one was 0.23 something. If you were to add them up, you will realize that the total is 4.22 exactly. Yes, sir. Question. If you have a question, write it down. Explain 3.99 again. S is equals to ut plus half at squared. Initial displacement is 78. Initial velocity is 0. Half into 9.81 t squared. You work out the value for t, 3.99. This is the time. If I were to talk about this well, this is the time for the stone to drop to the bottom of the well. So this is the time it takes for the stone to drop to the bottom, 3.99. See? And then for sound to travel up, it takes 0.24. So initial is 0 because it has been dropped as opposed to thrown. So the initial velocity is 0. Question number 6 says a toy car moves in a straight line. A toy car moves in a straight line. The graph shows the variation with time of the displacement of the car from its initial position. A student investigates whether forces acting on the car are in equilibrium at 4 different times, T1, T2, T3, and T4. At which times are the forces on the car in equilibrium? So the forces will be in equilibrium. That means that the net force is 0, which means that the acceleration is 0, which means that the velocity is constant. So displacement time graph, the gradient of the graph gives you velocity. So the object is at rest initially. The velocity is 0. At this point, the velocity is constant because the gradient of the graph is constant. Once again, velocity is 0, the object is at rest. And then the velocity is constant because the gradient of the displacement time graph is constant. Which means at all of these positions, T1, T2, T3, and T4, for the entire duration, the object either has 0 velocity, which is also a constant value, or some other non-zero constant velocity, which means that the acceleration is 0, which means that the net force is 0, which means that the object is in equilibrium. So at which times are the forces acting on the car in equilibrium? T1, T2, T3, T4. A car travels along a horizontal circular road of radius 12 meters, as shown. The car takes a time of 4 seconds to move from position P to position Q. So the car travels like this from position P to position Q. What is the magnitude of the average velocity? When we talk about average velocity is basically displacement upon time. Now, even though this is the path that is taken by the car, when you talk about the displacement has nothing to do with the actual path taken. Displacement is the shortest distance between start and end. It is the shortest distance between start and end. Right? So the shortest distance between the start and the end is this position. And if this is 12, this is 12, this will be under root 12 squared plus 12 squared according to Pythagoras' theorem. And we would say this is equal to under root 288. 12 squared is 144, 144 plus 144 is 288. So this is under root 288. So displacement would be under root 288. Time is 4 seconds. And that gives us the average velocity of 4.24 meters per second. A. So if it was distance, then if they asked you for the average speed as opposed to average velocity, you would find out this distance here. Okay? This distance here. Question number 8 says a person is suspended from a rope vertically below a helicopter. The helicopter and the person are stationary above the ground. Which forces forms a Newton's third law force pair with the weight of the person? The weight of the person is basically the earth pulling the person down. So one thing that you need to remember as far as the Newton's third law is concerned, that the reaction should be between the two same things. In this case, the weight, when we talk about the weight is between the person and the earth pulling the person down. So the reaction should also be between these two. You cannot have the rope interfering in between and and you can't consider that as the reaction. You can't consider the helicopter exerting a force and that as the reaction, because when you talk about the weight is between the earth and the person. So the reaction is the person pulling the earth upwards. So the gravitational force applied by the person on the earth, as odd as it may sound, the gravitational force applied by the person on the earth, but that is what an action-reaction pair is. Question number 9 says two small moving particles collide. After the collision, the particles move in different directions. What is essential for the total momentum to be conserved? No external forces act on the system of the two colliding particles. Yes, that is necessary. No kinetic energy is lost. That only happens in case of elastic collision. The collision is inelastic, not necessary. The relative speed of approach of the two particles is equal to the relative speed of separation. No, that is not a requirement. For momentum to be conserved, the system should be closed. There should be no external force acting on the objects. Block 1 of mass 3 kg is on a horizontal frictionless table. A rope with negligible mass is attached to the block. The rope passes over the frictionless pulley. Block 2 of mass 1 kg is suspended from the other end of the rope as shown. The blocks accelerate. The acceleration of free fall is g. The unit of g is meters per second squared, and the tension in the rope has the unit Newton. What is the tension in the rope in terms of g? Now, they have told us that the blocks accelerate. And then they're asking you, what is the tension in terms of g? What is the tension in the rope in terms of g, given that this one has a mass of 3 kg, this one here has a mass of 1 kg. Is this clear? Do you get the question? So, if we talk about the tension here, the tension in the rope pulls block 1 to the right. The tension in the rope is responsible for the acceleration of the block. Let's call that A. So I can say, using the formula net force is equals to mass times acceleration, I can say tension is equals to 3 times A. Now let's look at block 2. Block 2 experiences the tension downwards, upwards, and block 2 experiences its force, a weight downwards. This is weight. So for block 2, using the same formula, net force is equals to mass times acceleration. We will say W minus T is equals to M, which is 1A. And W happens to be 1 times G, where G is 9.81 or whatever value that is, जो G यहाँ पर इन्होंने दिया हुआ है, हम वही चीज यूज कर रहे हैं. Both T's are same. The tension throughout the rope stays the same. The tension does not change. So minus T is equals to 1A. Or I can say 1G minus 1A. I don't need to write down the 1s here. Is equals to T. Let's equate the two T's. This T is equals to this T. So 3A is equals to G minus A. And that means G is equals to just a second. T is equals to W minus T is equals to MA. Okay. 1G minus 1A. So G is equals to 3A plus A. G is equals to 4A. I get it. I got a bit confused here, but I've got this sorted. So A is equals to G upon 4. I've got A is equals to G upon 4. Okay. I should have made A the subject of the equation and then substituted it, but that doesn't make any difference. What I can do now is I have a value for A. I want the value for T. I can plug this in here and I can say T is equals to 3G upon 4. Hence C is the answer. Okay. It would have been shorter, I believe, if we substituted A instead of T, but I got a bit lost along the way. Ab sahi hai. We've got it sorted. All well that ends well. Okay. Is this clear? Do you get this approach? Question number 11 says, the mass of an object can be determined by its relationship to other physical quantities. 3 relationships are shown. Resultant force on the object divided by acceleration. Resultant force upon acceleration. Net force upon acceleration. That is equal to mass. Momentum upon velocity. Yes, that is equal to mass. Weight of the object divided by acceleration of the object. If I divide the weight by the acceleration, does that give me the mass? No. Because there you may have multiple forces, not always. On the other hand, weight divided by gravitational acceleration will always give you the mass. But no, this will not. Like in this case. Weight minus T divided by mass, W minus T divided by this mass gives me the acceleration. Or divided by the acceleration gives me the mass. So 1 and 2 only are always correct. 3 may be correct, may not be correct, varies. Question 12 says, a basket is sliding on a horizontal frictionless surface with a velocity of 30 centimeters per second. The mass of the object is M. A block of mass 2M falls vertically into the basket. The block and the basket then move together with the same horizontal speed V. What is V? So, law of conservation of momentum. initial momentum is equals to my final momentum. My initial momentum is m multiplied by 30 is equals to my final momentum, which would be m plus 2m. The two masses continue together, multiplied by v. So 30m is equals to 3m into v. The m's cancel out. V is equals to 10 centimeters per second. V is equals to 10 centimeters per second. Question 13 says two children are balanced on horizontally in equilibrium on a plank. Child X has a mass of 20 kg. Child Y has a mass of 15 kg. The plank is uniform with a mass of 7 kg and a length of 3 meters. There is a pivot at the midpoint. So it's uniform, which means that the center of gravity lies at the exact center, at the geometric center at 1.5 meters from either end. Child X has a mass of 20 kg and its distance x. Child Y has a mass of 15 kg and its distance y. What is the value of the ratio of x and y? Not an issue. The weight, the force that child X exerts is 20 g, where g is equals to 9.81. And the weight that child Y exerts is 15 g. Since the plank is balanced, it's in equilibrium, I know that my moment in the clockwise direction is equals to my moment in the anti-clockwise direction. My clockwise moment being 15g into y is equals to my anti-clockwise moment being 20g multiplied by x. The g's cancel out. For the value of x upon y, I'll have to do 15 upon 20 is equals to x upon y, which means 5 3s are 15, 5 4s are 20, 3 upon 4, which is equals to 0.75 as a decimal. The answer is C. So this question is also a repeat from one of the previous years. The diagram shows the two ways of hanging the same picture. In both cases, the string is attached to the same points on the picture and looped symmetrically over a nail in a wall. The forces are shown are those that act on the nail. The weight of the string is negligible. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of the forces are correct? So you've got the same picture hanging. Since you've got the same picture hanging, the downward force, which will be the weight of the pictures, would be identical in both the cases. Which means if it's in equilibrium, R1 should be equal to R2. The upward force here should be equal to weight. The upward force here should be equal to weight. And since the two weights are equal, R1 should be equal to R2, which gives me the answer as either A or B. Now, as far as tension is concerned, T1 cannot be equal to T2, which means that the answer is B. Okay? But then the question arises, what if we had an option where they said T1 is less than T2? Or why is it that T1 is greater than T2? To understand that, you need to think of it this way, that you'll have a vertical component of T1 and the vertical component of this T1, both these part of the strings. And these two vertical components downwards, they'll balance out R1. ये जो नीचे वाले दोनों कंपोनेंट्स है टेंशन के, वो R1 को बैलेंस करेंगे ना. अब अगर ये एंगल ज्यादा होगा तो इस वैल्यू को बड़ा होना पड़ेगा ताकि उसका कंपोनेंट इतना आ जाए कि वो R1 को बैलेंस कर दे. सही सर, वेट के साथ टेंशन का कंपोनेंट ऐड होके R1 बनेगा? नो 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 नो. If you look at this entire thing, you'll see W and R1. If you look at this part of the nail, then you take T1 and R1. R1 is the force that these strings apply on this nail. Okay? I hope this is clear. For the other one, since the angle is smaller, a smaller value for T2 will result in balancing R2. The diagram shows 4 metal cylinders submerged inside a container of water. Which cylinder has the greatest pressure on its top surface? Pressure is equal to rho g h. So they're in the same liquid. Rho is constant. They experience the same value for g. Pressure is directly proportional to h, where h represents the depth of the water. C is at the deepest point, so will experience the greatest pressure. 3 solid objects P, Q, and R are shown. The dimension and masses of the objects are given in length of x and mass m. Which objects have the same density? For density to be same, mass upon volume should be same. So for the first one, it is mass upon x cube. Mass upon volume, since it's a cube, x into x into x, x cube. For the second one, it will be 4m upon 2x into x into x, or I can say 4m upon 2x cube, and then I can cancel this out, and that gives me 2m upon x cube. So I know the density of this one is not equal to the density of this one. P and Q are not same. So that automatically eliminates A and B. Now it's either P and R or it's Q and R. When you talk about R, mass upon volume, volume will be pi r squared h, pi x squared into height being x upon pi. So the pi's cancel out and you end up with m upon x cube, which is exactly identical to P. So P and R have the same density. Q, on the other hand, has a density which is 2 times the density of P and R. A small ball is projected into the air from horizontal ground. The diagram shows part of the path. The ball leaves the ground at point X with a kinetic energy of 8 joules. A short time later, the ball is at point Y where it has a kinetic energy of 3.5 joules. Point Y is at a vertical height of 8.8 meters above the ground. Air resistance is negligible. What is the mass of the ball? So, energy at X should be equal to the energy at Y. Law of conservation of energy, you've got no losses. Energy at X is only kinetic energy. Energy at Y is kinetic energy plus potential energy. Kinetic energy at X is 8 joules. Kinetic energy at Y is 3.5 joules. Potential energy at Y is mgh, m into 9.81 into the height, which is 8.8, and that gives me the mass as 0.052 kilograms. So you have the initial, this was 3.5 joules and not 3.5 h. Here we go. So 8 minus 3.5, which gives you 4.5 divided by 9.81 into 8.8, and that gives you the mass as 0.052. A boat requires a power P to move through still water with a constant velocity. 3.5 joules. G, 3.5 joules. This is 3.5. This is 8. There's a drag force acting on the boat. What is the velocity of the boat? So they've given us the power. They've given us the force. They've told us it's moving at a constant force. a constant velocity, which means that the backward force, the drag force, is equals to the forward force due to the engine. And that means power is equals to force multiplied by velocity. Hence, velocity is power upon force. The answer is C. Question number 19 says, when the speed of an object is increased from 10 meters per second to 20 meters per second, its kinetic energy increases by E. So we have doubled the speed. We have doubled the speed. And kinetic energy is directly proportional to V squared, half mv squared. Half mv squared. So when we have doubled the speed, that results in the energy being increased by a factor of 4. जिसको वो कहते हैं कि जी increases by E. What is the increase in kinetic energy of the object when its speed increases from 70 to 80? 70 to 80. Okay. Change in kinetic energy. Let's try to do this directly. And there's a lengthier way where you plug in the values and get an answer. Is directly proportional to, change in energy is directly proportional to V squared minus U squared. Half mv squared minus half mu squared. Okay. So change in energy here is E. And we went from 10 to 20. 20 squared minus 10 squared. Okay. What will be the increase in energy if you go from 70 to 80? And let's work it out. 80 squared minus 70 squared divided by 20 squared minus 10 squared. And that gives me the answer as x being equal to 5e. C is the answer. You get it? आपकी velocity change हो रही है तो आप उसको change in energy को you cannot write it as half m delta v squared. You cannot do that. Do you get it? You need to write it as change in energy as half m v squared minus u squared. And a squared minus b squared is not equal to a minus b whole squared. This here is also a repeat question. Train supply coal to a power station. The table shows quantities describing the operation of the power station. Which expression gives the efficiency of the power station? Efficiency is power out upon power input. Now, the power station has an average output of P. So we've got that sorted. P. Let's talk about power input here separately. The number of trains per day. Number of trains per day. Number of trains per day. Power in is energy. Let's do it this way. Energy upon time. Energy is, number of trains is n. With each train having a mass of m. And each kg of coal gives you energy equal to E. Per unit time, with the number of seconds in 1 day, where does this 1 day come from? The number of trains per day. S. So you will say N M E upon S, which means PS upon N M E. The answer is A. And as I said earlier, it's a repeated question. Yeah. Which descriptions of objects undergoing elastic and plastic deformation are correct? Objects undergoing elastic deformation, not permanently deformed. Objects undergoing plastic deformation, they are permanently deformed. The answer is D. A force F extends a length L of a uniform wire by an extension of E. The wire has a diameter D and obeys Hooke's law. What is the Young modulus of the material of the wire? So Young modulus is FL over A delta L. Force into length upon area into change in length. Force is F. Original length is L. Area. The diameter is D. So pi R squared. A pi D squared upon 4. Whatever you think is easier. Multiplied by the extension which is E. Which means F L, and you've got 4 here, into pi D squared E. Where does this 4 come from? This 4 here comes from this 2 squared. So 4FL upon pi D squared D, which gives you the answer as D. Question number 23 says an 8 Newton weight is attached to the lower end of a spring, which is fixed at its upper end. The weight is initially held at rest at position X, and the spring is unstretched. The weight is then released and falls to position Y, which is 4 centimeters below X. The weight oscillates and then eventually comes to rest at position O, which is 2 centimeters below X. How much energy is lost from the system? Now, when we talk about the energy loss from the system, from position X to the final position, which is O, elastic potential energy of the spring increases because it extends. How much does it extend by? 2 centimeters. So elastic potential energy increases half Fx, half into 8 into 0.02, and that gives me 0.08. This is the elastic potential energy that increases. And the gravitational potential energy decreases. And it decreases by mg delta h, 8 multiplied by 0.02, which is equals to 0.16. So it decreases by 0.16. What is the net change? 0.16 minus 0.08, and that is equals to 0.08 joules. B being the answer. Is this clear? Guys, do you get it? Okay, perfect. Let's continue. Achha, so you want me to go over this again? You need to understand from this position to this position, the elastic potential energy increases because the spring stretches. कितना increase है? Half Fx से हमारे पास आ जाएगा. Number 1. Then gravitational potential energy decreases. How much does it decrease by? Mg delta H gives you that value. The difference between the two gives you the change, the loss of energy. An electromagnetic wave has a frequency of 3.3 into 10 raised to the power 14 hertz. Which principal region of the electromagnetic spectrum is this wave in? So you either need to remember the electromagnetic spectrum or in terms of the frequency, or you need to remember the wavelengths. So if you talk about the wavelength, which is relatively easier to remember, lambda is equals to V upon F, 3 into 10 to the power 8 upon frequency, which is 3.3 into 10 raised to the power 14. And that gives me 9.09 into 10 raised to the power minus 7 meters, which I can say is 909 nanometers. As far as visible light is concerned, visible light is 400 nanometers to 700 nanometers. And this part here is violet. This part here, the longer wavelength is red. So this here lies somewhere over here. Agreed? So it will be greater than red. This will be infrared. This will be infrared. Is this clear, guys? Question number 25 says, a wave on an unstretched string causes the particles on the string to vibrate. The diagram shows part of the spring at one instant. P, Q, and R are particles on the string. Which statement about the two of the particles on the wave is correct? It is a progressive wave. Particles P and Q vibrate with a phase difference of 90 degrees. No. If it is a stationary wave, so this would be 90, this would be 90, this would be 90. Okay, P and this point here, or this point here. If it is a stationary wave, particles P and Q vibrate with a phase difference of 90. No, in that case, it's 0 degrees. If it is a progressive wave, particles Q and R vibrate with a phase difference of 180. No. P and this point would be 180, half a wavelength. If it is a stationary wave, particles Q and R vibrate with a phase difference of 180 degrees. That is right. That is correct. Because this loop and this loop, these two loops are out of phase from each other. Which means any point on this part and any point here will be 180 degrees out of phase. And if it is 180 degrees out of phase, that means D is the correct answer. Question 26 says, what describes the displacement of a particle on a wave? The distance in a specified direction of the particle from its equilibrium position. That looks correct. Let's go through the other options. शायद वो बेहतर option हो थोड़े से. The distance moved in a specific direction by the particle per unit time. So distance per unit time is speed. The maximum distance of the particle from its equilibrium position, that is amplitude. The product of speed of the wave and time, that is not displacement. Okay. This question also looks repeated. At least it looks familiar. A beam of vertically polarized light of intensity I0 is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of 60 degrees to the vertical. The transmission light beam is then incident normally on a second polarizing filter. The transmission axis of the second filter is perpendicular to the vertical, so it's horizontal. The intensity of the light beam that emerges from the second filter is IT. What is the ratio? So let's say light here is I0. After passing through the first one, it will be I0 cos 60 squared. So here you'll have I1, where I1 is equal to I0 cos 60 squared. And after passing through the first polarizing filter, your light will be incident in this direction. at an angle of 60 degrees to the vertical, which means the second transmission axis would be at an angle of 30 degrees. So IT will be I1 cos squared 30 or cos 30 squared. And I1 in itself is I0 cos 60 squared into cos 30 squared. तो यहां मैंने क्या किया है, पहले मैंने I1 फाइंड किया है इन टर्म्स ऑफ I0 cos 60 होल स्क्वायर्ड. फिर मैंने जब I0 फाइंड करना था, IT फाइंड करना था, तो IT इज I1 whatever this is multiplied by cos 30. Why 30? Because then this light here after passing through the first axis will be at an angle of 30 degrees. And when I replace I1 with I0 cos 60, this is what I get. So IT over I0 is equals to cos 60 squared cos 30 squared, which is equals to 0.19. 0.19. B is the answer. A car is driving along a straight road while emitting a sound of a constant frequency. There is a stationary observer at each location X, Y, and Z. From X to Y, the car accelerates uniformly from rest up to a high speed. So, speed increases, observed frequency increases if moving towards. Okay? From Y to Z, the car continues at this constant high speed. Okay. Which observer will hear the highest frequency of sound, and what is the position of the car when the frequency is heard by the observer? So, the highest frequency would be when the speed is highest and moving towards. So, that automatically eliminates X. Because at any given point, this car is moving away from X. So this cannot be the answer. This is incorrect. It's either Y or Z. Now, the maximum speed of the car will be at position Y. Because it's accelerating from X to Y. And when it is at position Y, the person standing over here will hear the actual frequency. Because at that instant, nothing happens. It's neither moving towards or away. At that instant, you've got that transition happening. From Y to Z, speed is max. Speed is max. But at this point also, it's moving away from X and Y. It is moving away from X and Y. Moving towards Z. So Z between Y and Z. जब वो Y से Z जा रहा होगा, उसकी स्पीड सबसे ज्यादा होगी, सही है, और टुवर्ड Z जा रहा है तो Z को जो फ्रीक्वेंसी सुनाई देगी वो एक्चुअल से सबसे ज्यादा है. X और Y से दूर जा रहा है, they will hear a frequency that is less than the actual frequency. Which diagram is labeled correctly for a stationary wave? Node to node is half a wavelength. This is half a wavelength. So it's either this or this based on just how wavelength is represented. Then when we talk about positions, this here is an antinode. No, this is not an antinode. This is an antinode and this is a node. So correct, D. Pretty simple. Question number 30 says, two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Which statement about the waves is not correct? Intensities are different, which means their amplitudes are different, but they are coherent. They have a constant phase difference at this point. This is correct. They have the same amplitude. No, because intensity is directly proportional to amplitude squared. They will have the same frequency. Yes, they are coherent. They travel at the same speed. Yes, because they're electromagnetic waves in a vacuum. Laser light of a single frequency is incident normally on a diffraction grating with 5 lines to 10 to the power 5 lines per meter. A diffraction pattern is formed on a flat screen. The screen is a distance of 33.5 centimeters from the grating. The distance between the two first order is 15 centimeters. What is the wavelength of light? So let's say this here is my diffraction grating, and this here is my screen. And on my screen, I'll have my zero order here. This here will be my n is equals to 0. This here would be my second order. You'll have a first order in between. We're not talking about that right now. This is n is equals to 2. और फिर यहाँ पर नीचे आपके पास n is equals to 2 होगा at an equal distance. The question says the distance between the two first order is 15 centimeters, which means this here is 7.5 centimeters. And the screen is at a distance of 33.5 centimeters. Now, the thing with the formula for diffraction grating is that you need the angle from the zero order as opposed to these distances here. So we can use Pythagoras' theorem to find out theta. And that gives me tan theta is equals to opposite upon adjacent. So I get my value for theta. I get my value for theta as 12.62 degrees. What do I need now? I need to find out the wavelength. D sine theta is equals to n lambda. D is 1 upon 5 into 10 to the power 5. Sine theta is 12.62 is equals to n is 2. Lambda is my unknown. So sine 12.62 divided by 10 exponent 5. No, n is equals to 2 ना. The distance between the two first order. बच्चे हमने जो एंगल निकाला है वो एंगल किसका निकाला है? वो फर्स्ट ऑर्डर का निकाला. हमने जो एंगल निकाला है वो तो सेकंड ऑर्डर के लिए निकाला है. नो, जस्ट अ सेकंड. Here, let me have a look at it. Two first order. Sorry. I made a mistake here. Here. This is two first order. ठीक है. N is equals to 1. You are right. And that means this here will be 1. Misread it. So that gives me the answer as 437. Lambda is equals to 437 nanometers. Thank you for pointing that out. 437 nanometers. Which graph represents the variation with current I of the potential difference V for a filament lamp? Filament lamp is one which experiences an increase in resistance. R is equals to V upon I. So, as far as the filament lamp is concerned, in case of a filament lamp, what happens is your V increases more drastically as opposed to your I. That results in the R increasing. So the answer is B. What is the definition of potential difference across a component? The energy transferred per unit charge. This is right. Energy transferred per unit time, that is power. The power transferred per unit current, that is voltage potential difference. Power upon current, power is equals to VI. Yes. The product of current and resistance, and that is also potential difference or voltage. Question number 34 says, conducting putty is a substance that conducts electricity and can be molded into various shapes. A cuboid made from this putty has a length L and width X. The resistance between the surface square faces is 15 ohms. Some more of the putty is molded into a cylinder that has a length L by 2. The resistances between the circular faces of the cylinder is also 15 ohms. Okay. What is the radius of the cylinder? Now you need to understand that it's the same putty. The resistance is same. Same putty, same resistance. R is equals to rho L upon A. The resistance was initially 15. So this is also 15. Now, the area here is X squared. Okay. If I half the length, if the length is halved, to get the same area, to get the same resistance, the area should also be halved. So for the cylinder, the area need to be, the original area is X squared, the area should be X squared upon 2. Because length halved, area halved, the two halves cancel out, you can end up with the same resistance. So, which means the area of the cylinder should be equal to X squared. The formula for the area of a cylinder, the formula for the area of a cylinder is pi r squared h. Pi r squared h. So pi x squared upon 2, sorry. Pi. Now you'll have a cylinder here. Let me draw it. You'll have a cylinder here. And this cylinder here has a length L by 2. And let's say it has a radius r. So pi r squared into h, the height, which is L upon 2. And this is equals to X squared. Now, do we need the answer in terms of L? We don't. Oh, my bad, guys. The area of the cylinder, we are talking about the area of the circle, cross-sectional area. So pi r squared is equals to X squared. What I wrote earlier was the volume of a cylinder, which is not needed. So area is equals to X squared upon 2. R squared is equals to X squared upon 2 pi. Square root both sides. X upon under root 2 pi. X upon under root 2 pi. Do you get it? Good question. Prone to making mistakes. Each of the Kirchhoff's laws is linked to conservation of a physical quantity. Which conserved physical quantities are used in the derivation of Kirchhoff's first law and of Kirchhoff's second law? First law is current entering is equal to current leaving, which follows conservation of charge. The second law is for a closed loop, the total EMF is equal to the total IR, which is conservation of energy, which means that the answer is C. Eight identical resistors are connected as shown. Ammeter A1 reads 1.5 ampere. What is the reading on ammeter A2? Okay, not an issue. Let's backtrack. Let's say you've got a current of 1.5 ampere here. If you've got a current of 1.5 ampere here, which automatically means because the top branch has 2 times the resistance, the current will be half. So the current in this case will be 0.75 amperes. Has to be. Which means the current here is 2.25. Which means that the current here is 2.25. And I've got 2 resistors here and I've got 3 resistors there. The top branch will have more current than the bottom branch. So I can just find out the split. I can say I've got 5 resistors. The top one will have 3 upon 5 into 2.25. 3 upon 5 into 2.25. No. Don't go fall for that trap. This will be 1.35. And 2 divided by 5 into 2.25, 0.9. You will have 0.9 here. The reason I'm saying don't fall for that trap is if you go with 2 upon 5 here, this one gets 0.9. And then this one gets 1.35. The path having more resistance gets more current. You need to understand, for the same voltage, R is inversely proportional to I. Inversely proportional. Do you get it? G, voltage in parallel will be same, but if it was voltage in series, you would do it this way. So you will have 1.35 amperes here and this. A battery of EMF 6 volts and negligible internal resistance is connected in series with a resistor of resistance 6. Most common answer would be B. Maybe, yes. That is the most common incorrect answer. That could be B. A voltmeter is connected across the variable resistor. The resistance of the variable resistor is changed. What is the range of the voltmeter reading? So when the variable resistor is at 0 ohms, the reading on the voltmeter would be 0 volts. Because there is no resistance, there will be no potential drop. Has to start off with 0 volts, so either A or B. When it's at 4 ohms, let's work it out. When it is at 4 ohms divided by total resistance, which is 4 plus 6 ohms, multiplied by the EMF, which is 6 volts. So this gives you 2.4 volts. Okay. Or I could have just seen that this 4 ohms is lesser than the 6 ohms. It can never get more than 50%. It can't even get 50%, let alone more than 50%. So it can't go up till 3.6. This one here gets a maximum of 3.6 volts, a minimum of 3.6 volts. In the alpha particle scattering experiment, a beam of alpha particle is aimed at a thin gold foil. Most of the alpha particles go straight through or are deflected by a small angle. A very small proportion are deflected by more than 90 degrees, effectively rebounding towards the source of the alpha particle. Which conclusion about the structure of atoms cannot be drawn by this experiment alone? Most of the atom is empty space. Yes, that can be drawn. Most of the mass of an atom is concentrated in the nucleus, can be drawn. The nucleus contains both protons and neutrons. No way to justify that using this experiment alone. Neutrons हैं नहीं हैं, exist करते हैं नहीं करते हैं, हमें क्या पता? The nucleus is charged, yes, because the alpha particles get deviated. Question number 39 says, in a type of a beta decay, an up quark changes to a down quark. up quark changes to a down quark. Which row shows the new hadron created in this decay and the sign of the charge on the emitted beta particle? So basically, up down gets converted to an up down down. So a proton, basically, a proton gets converted into a neutron, where a proton is up down and a neutron is up down plus a beta plus a beta plus. So the answer is A. The hadron created is neutron. Number 40 says uranium decays into radium after a sequence of alpha and beta minus decay. Which row gives the number of alpha decays and the beta minus? Best way is to make an equation. Uranium 238 92 gives you radium 226 and 88 plus X number of alpha decays and Y number of beta decays. Let's look at the alpha decays first. If you look at the nucleon number, you can figure out the alpha decays. This is 238, this is 226, which means there's a difference of 12 here, which means 3 alphas. You have 3 alpha particles, 3 alpha particles. As far as the beta decays are concerned, this is 92, this would be 3 2s are 6 plus 8, plus 88. 88 plus 6 is 94, which means you need beta decays. You cannot have 0 beta decays. How many beta decays do you need? You need 2 beta decays. So the answer is B.